Hi, everybody. Wish me luck. This is the first time I'm doing a live Facebook presentation. So good evening, fellow CCRNs and soon-to-be CCRNs. Tonight's discussion will be on Swan-Ganz catheters, figuring out what the correct wedge is when someone's on a PEEP. And it has to be a PEEP greater than 10. Any PEEP less than 10 will not affect your wedge. So any PEEP greater than 10 will affect the wedge pressure that you get. And so the calculation that you could use in order to get the accurate wedge, and that's what we'll be doing. Let me see who's on here. So good, we got a few people on already. That's good. You know, swans came out back in the 70s, before probably most of you were born. I was a nurse back then. I still am. I've been a nurse for over 48 years. But they came out in the 70s. And then in the 80s and the 90s, everybody had a swan. They were swanning everybody. You come in to pick up your paycheck. If you didn't walk quick enough, they'd swan you. They were just swanning everybody. Living people, dead people, everybody was getting swanned. And then after the 90s, the year 2000, it pretty much was tapered off and it fell by the wayside. But now it's on the upswing again. And because of that, you will see questions on the CCRN exam regarding Swan-Ganz catheters. You'll probably see about 3 questions. Okay, so let's start. Let's figure out calculating the wedge when someone is on a PEEP, and it has to be greater than 10. So, okay, that's not good. Here we go. All righty. So, you know, PEEP is measured in centimeters of water, and the wedge is measured in millimeters of mercury. So in order to get an accurate reading, what you have to do is you have to change the PEEP, which is centimeters of water, into millimeters of mercury. And how you do that is you use an equation, a very simple one. You take the PEEP that the patient is on, and it has to be a PEEP greater than 10. You take that PEEP and you will divide it by 1.36. You get a number, and then you divide that number by 2. And then you take the remaining number and subtract it from your wedge. So right now, we just need to know that we have to take the PEEP and divide it by 1.36. And then take that number and divide it by 2. And I'll show you what to do with it. So what we have to remember is you got to take the PEEP and divide it by 1.36, and then divide it by 2. Now on the exam, they don't use pulmonary artery wedge pressure. They don't use that. They use pulmonary capillary occlusion pressure. So on the exam, just be aware that they'll be using pulmonary capillary occlusion pressure and not saying wedge pressure or pulmonary capillary wedge pressure or pulmonary artery wedge pressure. They use PCOP. So what we have to learn at this point in time is you take the PEEP, you divide it by 1.36, and then you divide it by 2. And then we're going to take that number and subtract it from our recorded wedge in order to get our real wedge. All right, so let me show you how it all works. Let's say you have someone on a PEEP of 15. You did a wedge pressure, and you got a wedge pressure of 18. That's not an accurate wedge pressure. Why? Because he's on a PEEP greater than 10. Being on a PEEP greater than 10 increases your interthoracic pressure, and it'll affect your wedge pressure. So what you have to do is you have to take the PEEP, which is 15, and divide it by 1.36. You come out with 11. And then you take that number and divide it by 2. And you come out with 5.5. And it is that number that you're going to subtract from your recorded wedge in order to get your real wedge. So my recorded wedge was 18, but I'm going to subtract the 5.5 that I got in order to get the real or the correct wedge, which is 12.5. So here we had someone with a wedge of 18, but his real wedge is really 12.5. Here, when you got that recorded wedge of 18, people are probably running around saying he's fluid overloaded. We better, maybe he's in congestive heart failure. Maybe we've got to give him this. Maybe we've got to decrease the fluids. When really, he probably couldn't go, well, he can't go home. He's on a PEEP of, what do you call, 15. Never mind. Anyway, so you see, this is what you got. But after you do the mathematical equation, this is what it really is. And for many, many years, no one was doing any of this. We were just taking this, and then treatment was given to the patient. And obviously, it wasn't the proper treatment because we didn't do this. Okay, so let me do more. Let me show you how easy this is. You have someone on a PEEP of 20. Now, you got a recorded wedge of 22. Or on the exam, it'll be PCOP, Pulmonary Capillary Occlusion Pressure. But anyway, you got a wedge of 22. That's not an accurate wedge. Why? Because he's on a PEEP of 20. So what you have to do is you have to take the 20 and divide it by 1.36. And you get 14. And then you divide that by 2 and you get 7. Then you subtract that 7 from your recorded wedge in order to get your real wedge, which is 15. So here you were having a wedge of 22. Everyone's running around saying he's in failure, when really he is not. You have someone on a PEEP of 14. You got a recorded wedge of 12, but that's not the real wedge because he's on a PEEP greater than 10. So what you have to do is you have to take the PEEP, which is 14, divide it by 1.36, and you get 10. Divide that by 2, and you get 5. And you take that number, you subtract it from your recorded wedge in order to get the real wedge. So the recorded wedge was 12, but the real wedge is 7. So there's a big difference there. The next one says you have someone on a PEEP of 18. You got a recorded wedge of 16, but that's not the real wedge. Why? Because he's on a PEEP of 18. So you take the PEEP of 18, you divide it by 1.36, and then when you do that, you get 13. Divide that by 2, and you get 6.6. And you subtract the 6.6 from the 16 in order to get 9.5. So here you thought the wedge was 16, but really the wedge is 9.5. Let's do one more. You have someone on a PEEP of 16. You do a recorded wedge and you get 11. That's not an accurate wedge. Why? He's on a PEEP greater than 10. So you take the 16, you divide it by 1.36, and you get 11. Divide that by 2, and you get 5.5. And you subtract the 5.5 from the 11 to get a wedge of 5.5. So here you thought he was fine, but now he might be fluid depleted. So in order to calculate the true wedge when someone's on a PEEP greater than 10, what you have to do is you take the PEEP, you divide it by 1.36. Then you divide it again by 2. And you take that number, subtract it from your recorded wedge in order to get your correct or real wedge. Anybody got a question? Let me see. Not yet. I don't see any questions yet. Okay, good. Let me just take another minute or two of your time and tell you that the primary method to ensure accuracy in interpreting a wedge is you have to locate the A wave and determine the mean. Most people, when they put air in the balloon to get the wedge, they look at the monitor and they take the number that's there. But you know, that machine will take the average height of all the humps it sees. So you will never get an accurate wedge by looking at the number on the machine. The machine still does not give you a normal accurate number because it averages out the height of all the humps on the screen in a given frame. And so it's not accurate. So let me tell you how to get an accurate wedge, the number. This is very easy. Well, first of all, you know the mean of the A wave closely, or the wedge, closely approximates the pulmonary artery diastolic number, which is very similar to the left anterior pressure, which closely approximates the pulmonary artery wedge pressure, and the left ventricular end diastolic pressure. In other words, the A wave should be very similar to the pulmonary artery diastolic number, which is also reflective of the pressure in the left atrium, which is also, when the mitral valve is open, reflective of the pressure in the left ventricle. Okay, so let's talk about the A wave. When you put air into the balloon and you get a wedge, when you get a wedge, you'll see the waveform will change. When you put air into the balloon, you will see an A wave, a C wave, and a V wave. Now, the A wave is atrial contraction, the C wave is mitral valve closure, and the V wave is atrial filling. And when you see these waves, it's easy to identify them when you correlate them with the EKG that is usually above this reading. Let me show you. So you have A waves, C waves, and V waves. The A wave is atrial contraction, the C wave is mitral valve closure, and the V wave is atrial filling. So when you put air into that balloon, you're going to see A waves, C waves, and V waves. And just to review again, the A wave is atrial contraction, and you'll see it after the QRS. People say, well, that doesn't make any sense. If the A wave is atrial contraction, I should really see it under the P wave, because the P wave is atrial contraction. But the reason why the A wave, which is indicative of atrial contraction in a wedge reading, the reason why you see it after the QRS is because of the length of the tubing. The tubing is very, very long. When you're talking about someone with a swan, they have tubing that comes from the insertion site, and that tubing usually goes down somewhere near the floor, and then it comes up, and then it's on the transducer, and then after the transducer you have a wire that's definitely on the floor, and then the wire goes up and goes up to the EKG monitoring machine. And so what happens is the waveform, the mechanical waveform in the tubing, the water, the solution in the tubing has a mechanical waveform. And that mechanical waveform goes through the tubing, and then when it reaches the transducer will take that mechanical waveform and convert it into an electrical form. And that electrical form then goes through the wiring and is projected up on the monitor. So the length of the tubing and the wiring is so long that the A wave, which is really atrial contraction, it should be under the P wave, it's found after the QRS, and I'll show you on an EKG. The C wave is closure of the mitral valve, and very often it's hard to see that. And the V wave is atrial filling, and it occurs after the T wave. Let me show you, let's see, yes, I do have it correlated with an EKG. So this is your EKG. If this is lead 2, you know he has a left axis deviation. This is a P wave, and then your QRS complex, and this is a T wave. P wave, QRS complex, inverted T, P wave, QRS complex, and a T. And in order to find the A wave, I have to look after the QRS. So that this hump here is an A wave. How do I know? Well, when I follow it, it's right after the QRS. This is the C wave, and then this wave is the V wave, atrial filling. It occurs right here after the T wave, in between the T and the P. So for example, this is an A wave. How do I know that it's an A wave? Because when I follow it, it's right after the QRS. This is a V wave. How do I know that? I follow it up. It came after the T wave. So it's very important when you're doing a wedge to find the A wave, because you will never take a number that is on the machine. You will always find the A wave and take the mean of the A wave in order to get an accurate wedge. And then if he's on a PEEP greater than 10, you're going to take that PEEP, divide it by 1.36, divide it again by 2, and take that number, subtract it from your recorded wedge in order to get your real or your true wedge. So, I don't know whether you could see this. It's a little teeny here, but this is the A wave. Why? Because it comes right after the QRS. So this is A wave. The top is 18, and the bottom is 11. So I take the mean of that. So it's probably around 15. So his wedge is 15. You would never look at the machine and get the number from the machine. So again, the A wave is found right after the QRS. And you take the mean of the A wave in order to get a wedge. And this is just one last shot of A waves and B waves. This is an A wave. Now really these all look very similar, but this is an A wave. How do I know? It's right after that QRS. Here you can't see the C wave, but you could definitely see the V wave, atrial filling. And it's right in between the T and the P. That's when it comes. So the A waves are found after the QRS, and the V waves are found after the T wave. And the V wave will be very, very elevated when people have mitral insufficiency. So just to sum up, when you do a wedge pressure, never take the number that's on the machine. You want to find the A wave, which is right after the QRS, and you take the mean of that A wave. And then, should your patient be on a PEEP greater than 10, you have to now get an accurate wedge. So what you do is you take the PEEP, divide it by 1.36, and then you divide it again by 2, and you take that number, subtract it from your recorded wedge in order to get your real wedge. And now you're off to saving lives. So let's see, we have any questions? Let me look on here. I'm new at this here. Let's see. Anybody got a question? Let's see. Oh, what are the normal ranges for a pulmonary capillary occlusion pressure? It's the same number for pulmonary artery wedge pressure or pulmonary capillary wedge pressure, and it should be anywhere from 6 to 12. Some books say 6 to 14. Some books say 8 to 14. So it should be in that range for a wedge pressure. Let's see, what else we got? Any other questions? No? Let's see. No. Okay. The mean of the A and the C waves. You're just going to take the mean of the A wave in order to get an accurate wedge. And that A wave is the hump you see right after the QRS. It correlates, comes right after the QRS. So you take your A wave, take the mean of your A wave, in order to get an accurate wedge. And just be aware, if someone's on a PEEP greater than 10, you have to do that equation. And that equation, see, is this. Divide your PEEP by 1.36, and then divide it again by 2. Take that number from your recorded wedge in order to get your real wedge. Okay, well, thank you. Thank you so much. Thank you for your attention, and I hope you share this. It's good information, and it'll help people with at least 3 questions on the CCRN exam, and maybe if you want, I could do this again maybe every week or every other week, little tidbits of things you need to know for the exam, all right? Thank you. Have a good night. Good luck to you. and live video. There we go. Let's choose